So in order to not only pass the AWS exam, but also to be a responsible AWS professional, you need to understand some really core and essential security best practices. So the first one being enable multi-factor authentication and reduce root access. So your root access, which gives you blanket access to your entire account, you really don't need to use that very often at all. If you're in a large organization, you would be using it, for example, to change your billing arrangements. Now, that's not going to happen very often, so you really need to get those credentials, lock them away, and try not to ever use them. And then you enable multi-factor authentication. So set up administrators and enable multi-factor authentication for each individual administrator. The next thing you need to make sure that you do is you grant least privilege. So what that means is that you start off with nothing. So really 0 privileges and start building it up for each user from there. So you don't start with a blanket access all and start reducing it from there. You work the other way around and make sure that you grant the minimum privileges, grant least privilege that is required for that person. Also create individual users. So it's very important that you create individual users, otherwise you're not going to be able to identify the root cause, the root user behind any issues that arise. So don't be tempted to use create one user one user account for multiple users. Create individual logins for each user. You need to, if you've got a large organization, you're going to have to manage those individual users and the permissions. So it's best to manage those with groups, and that way you can identify a best practice set of permissions for a group. So you might have administrators, they will have a certain level of permissions, and you would have a developers group and they would have a certain level of permissions. So, and then you put those users inside those groups and those users will inherit the permissions of those groups. So make sure that you use groups to manage permissions, don't manage the permissions directly with the user. IAM roles, use them to share access between different AWS accounts, and also use it for EC2 to access services within your account. So don't use credentials inside code to access for an application to access inside your account. Create an IAM role for that EC2 instance, and that EC2 instance will have permission to access within your account. Restrict further with conditions. So you might have a policy there that you can restrict it further. You can restrict it by making sure that, for example, multi-factor authentication was used to access that API call. So restrict further with conditions. So again, granting least privilege and restricting it even further. Use a strong password policy. So that's obvious, and make sure that you rotate those passwords regularly. And also rotate security credentials regularly as well. So they're the main security measures, and not the only ones, but the ones that you really need to nail and you need to be aware of, not only for the exam, but also to be a responsible AWS professional. So outside of AWS, there's some other security measures that also would be considered very important, that you should also be looking at implementing. So the first one being there is enabling AWS CloudTrail. So AWS CloudTrail will monitor and log API calls to all services within your account. So if you've got a user and they're accessing through the console, you will see everything that they're accessing will be logged. So when we say logging API calls, that doesn't necessarily mean through an application as such. It can be through the command line interface, or it can be through the AWS console, because that is an application in itself. So it really just logs all calls to services by users. So very good when you've got a problem to track down the root cause of that problem. AWS key management service. So again, if you've got encryption keys and the like, use this service to manage. It's a very, very good service for managing keys for encryption. and VPC security. So we'll learn a lot about VPC security as we go on into the course. So that's another added layer of security that you need. So the first of the best practices to apply is to enable multi-factor authentication and reduce root access to your account. So how that works is that we create a privileged administrator group and then we restrict root access. So we basically try not to use root access wherever possible. It shouldn't be required very often at all. And then once we've created an administrator group, we can add users to that administrator group, and those users will inherit that administrator privileges. And then we can make sure that that multi-factor authentication is applied for those users. So the way that we do that is that it applies a second level of authentication, and then we do that with either a virtual MFA application. So the most common one there would be Google Authenticator. So that's available for the iOS or Google Play for Android. So you just install that on your device, and then you have that access code for multi-factor authentication. There's also hardware solutions, so you can have hardware key fobs and that you can use that will generate a code for your multi-factor authentication. So the way that works is that the user will log in. You'll create a user, and that user will have a login access, and so they will put in their username and password that they will have to access that account, and that will get them into the security token service of IAM, and then that will then send back to the user a request to put in a multi-factor authentication code. So they will read that code off their hardware device, or they will read that off their Google Authenticator or whatever application they're using for MFA, and then they will type that in, and that will get sent back to security token service, and that will create then, if it's correct, it will validate that, and if it's correct, it will then create temporary security credentials that user can use to access the AWS resources. So they're not accessing the root account, they're accessing the administrator privileges, their administrator and part of that administrator group, and they're given temporary credentials to access that. So when we log in as a user, our access will be limited to what we can do depending on what group we belong to and what privileges we've got. So I'm just logged in here as a user to an account. And if I go into, say, for example, security credentials. So when I look at that, there's not a lot there that I can do. I can change my password, and that's about all I can do from that perspective. So, but when we log into the root access account, so I'm logged into a root access here. And if I go into security credentials, when I'm in the root access, you can see, first of all, it comes up with a warning saying that, well, you're accessing the security credentials page as root access, and you shouldn't really be doing that unless it's really essential. So I'm just going to click continue, and you can see that we've got a lot more access there. So really, these are the kind of things that we don't really need to access very often, and so with root access, we don't really need that. So certainly something to make sure that it is protected as much as possible. So the way you do that is here with multi-factor authentication. So how that works is we click on here, activate multi-factor authentication, and then we select whether we're using a hardware or a virtual MFA device. So just say we're going to use Google Authenticator, and we're going to put that on our phone, which is what you would normally do if it's a small business or it's your own personal account. You would use that. If it was a large organisation, you would probably use a hardware MFA device. So whichever one we'll go across to. So it's just saying that you need to install a MFA compatible app or an AWS MFA compatible application on your smartphone or PC or whatever. And I'll just click here. It says a list of those. So here you can see for Android, we've got the AWS Virtual MFA, and we've got Google Authenticator, the most common used application for that, and we've got Google Authenticator for iPhone, and we've got Windows Authenticator for Windows Phone, and Google Authenticator also for BlackBerry. So a number of options there if you want to set that up. So just click on the next step. So what that happens now is that when you've installed that MFA application on your device, you would scan that QR code, and that would give you a authentication code which you'd put in there, and then you'd scan it again, would give you another authentication code. So once you've done that, then you can click on Activate Virtual MFA Device, and that will set that up for you. Granting least privilege. So what that means is that when we're writing our policies for access, we make sure that we start with a default deny. So and then build it up for that. So make sure that there's no privileges to start with, and then we build up. We first of all identify those required permissions, and we build up our policy from that. We don't work the other way around. So when we get into later on in the course and we're starting to write our own policies, we try and avoid using wildcard policies that are more general, and try and make it more specific. So if we're looking for accessing to Amazon S3, we don't use a wildcard policy for buckets. We would actually define that bucket and the folder within that bucket that we would want access to. The other thing that we would want to do is use policy templates wherever possible. So AWS have got good quality templates in a very large library of those. So if we want to create an administrator policy, then we just grab one that they've created. So it's no point reinventing the wheel and creating more opportunity for errors there. So creating individual users. So we want to make sure that we don't share credentials between users, that we have each person that is accessing our resources, that they are set up as an individual user in IAM. So we're creating individual credentials, permissions, and we're rotating those credentials on a regular basis. So this enables us to use CloudTrail, the logging, the API logging service. We use that effectively so that we can, where there is a problem, or we can use that to identify that where there is any suspicious sort of activity on our account, we can use that to identify the user behind that. And you can create individual users using the console, using the command line interface, or using the APIs. So if you wanted to create an application to create users you can do that as well. So when we've got a lot of users, we want to manage those users with groups. So don't try and manage users on an individual basis. Manage them as a group. So and then map those permissions to a group based on the business function. So if you've got developers, make sure that they've got their access that they need, and only that access. If you've got administrators, if you've got general users, set up a group for those, and then when those users are put into that group, they will inherit those permissions, and nothing more and nothing less. IAM roles are very important for sharing access to your resources and for EC2 server instances to access your resources as well. So wherever possible, don't give out security credentials. So don't hand out security credentials to a third party. You would be crazy to do that. So don't do that. And the same with your EC2 server instances. If they need to access your resources, give that EC2 server instance a role, and that role will allow it to access the resources that you define. Never share your security credentials. So the use cases for roles is for cross-account delegation. So if you would like different AWS accounts to access your account, and intra-account delegation, where you would want different users to have delegation of access. And another very common use is with federated users. So what a federated user is that we might have a application, say a mobile phone application, and we want that user to be able to access, for example, our Amazon S3 account to store stuff on Amazon S3. So Instead of giving that user, creating credentials for that user, which would be virtually impossible. You might have 100,000 users. You're not going to be able to create credentials for those users, and it would be not a wise thing to do at all. So what we can do is we can use, for example, Facebook. We can use the login authentication for Facebook and use that to verify a user, an individual user, and then we can give them limited access on a temporary basis after they've logged into our Amazon Web Services. That's what we mean by a federated user. Another good best practice is if we're going to give external parties access to our Amazon account, then we should actually set up an external ID condition in that policy. So what that means is that you create a role, and then that role will have an ARN that third party can use through their Amazon account to access your Amazon account. So we want to make sure that there's another level of authentication on there using an external ID that will be inputted as well at the same time, which identifies that third party. When we're doing our policies, again, we can restrict that further with conditions. That provides an extra layer of security. So just the same as that we don't want to use wildcard symbols, we also want to actually further define our policies as much as possible. A good example of that here is that we can check if multi-factor authentication has been used for an API call. So there's a condition that we can put in our policy for that. So again, conditions help to provide that extra layer and to get it more specific, that access. We need to configure a strong password policy, so make sure the passwords expire on a regular basis. Make sure that the password policy requires a certain level of password strength. And make sure that passwords don't get reused. So we're using, so when a password expires, we have to create a unique and new password. Our security credentials, make sure that we rotate those. We can actually get a credentials report, and we'll have a look at that later on in the course. To identify if there are aged or unused credentials. So we don't want those lying around, get rid of them. They are a risk to us, so make sure that those are gone, because someone might leave the company and they still have those credentials on file, so we don't want that to happen. And grant users permission to rotate their own credentials as well. So there you have a very high level overview of the IAM security best practices that you need to understand to be a good quality AWS professional. And we'll just run through those now, just to make sure that you can remember those, and you need to make sure that you know these fully for the exam. Enable multi-factor authentication, reduce root access, grant least privilege. So start with a default deny, work up from there and identify what privileges are required, and then add those to it. Create individual users and add those individual users to groups and manage the permissions at a group level. Use IAM roles if you're going to share access to your resources, and if EC2 servers are going to be accessing other resources within your account, then do that using IAM roles. Restrict your policies further with conditions, so another layer of really defining that policy even further. Configure a strong password policy and rotate your security credentials on a regular basis. So the next thing is, outside of IAM, we need to also be aware of CloudTrail. Make sure that's enabled for monitoring and logging of all calls to the AWS services of your account. The AWS key management service for the management of encryption keys and the like. And for and VPC security, there's a lot of measures there that we will be looking at later on in the course. So make sure that you fully understand that before you take the course, and also throughout your career in AWS, make sure that you live and breathe these security best practices.